We now develop this even further. What we have here is a circle. If you know enough about circles, you'll recognise that this is a circle centred on the origin with a radius of 5. And we have a straight line. Again, the question is, where do these intersect each other? And again, we follow the same procedure as before. This is complicated. I don't really want to rearrange that. This is much easier to rearrange. So I'm going to start my thinking here. Now I could make x the subject and substitute it in there. I could make y the subject and substitute it in there. There's not much in it. Either way I'm going to end up with a fraction. That just can't be helped this time. But I think I would rather have a fraction with a denominator of 2 rather than 3. So for that reason, I'm going to make y the subject. 2y equals 18 minus 3x. Divide through by 2, y equals 18 minus 3x all over 2. And I'm going to substitute that into the circle. X squared plus y squared equals 25. X squared plus, now I could write this as double brackets, maybe I should for the moment. 18 minus 3x, 18 minus 3x, all over 2 squared, which is 4, equals 25. I do not like that fraction. I think the first thing I'm going to do is make sure I can get rid of that fraction. I'm going to multiply both sides by 4. Now, we need to think about how we're going to write this down. Writing it like that is all well and good. It's fine over here. The problem here is that I'm multiplying all of the left-hand side by 4, but in terms of BIDMAS, it only looks like I'm multiplying this by 4. This is being left out. But I need to remember that actually there's a great big bracket around all of the left-hand side. This 4 needs to affect this fraction just as much as it affects that x squared. So what I'm going to do, I'm also going to put a times 4 in there. I'm basically expanding that big bracket so that the 4 affects both of them. 4x squared plus, those 4's cancel, which was the whole point of multiplying by 4 in the first place. So I'm just left with 18 minus 3x, 18 minus 3x equals 100. 4x squared plus 324 minus 54x minus another 54x plus 9x squared equals 100. Simplify the left-hand side. 13x squared minus 108x plus 324 equals 100. It's a quadratic. I have to set it equal to 0. That is the only choice that's worth following. So 13x squared minus 108x plus 224 equals 0. Now again, if that factorizes, then it's definitely the way to go. How can I tell whether it factorizes? I don't want to waste my time. Well, in the quadratic formula, there is something called the discriminant, b squared minus 4ac. If I just work out b squared minus 4ac, so negative 108 squared minus 4 times a times c. If when I press equals, if this produces a square number, then it definitely factorizes. If it doesn't produce a square number, then it doesn't factorize. There's no way. So I'm interested in whether I get a square number or not. And I've got 16. This definitely factorizes. So I can start into this absolutely confident that it can be done. I'm very fortunate that's a prime number. It means there's only one option here, 13x times one single x. Now, after a little bit of thought, I can conclude that 4 times 13 and 56 times x works very nicely. As ever, once you've done that, or you think you've done that, you'd re-expand it to make sure that it's working. This one does. I now know that 13x take 56 equals 0, and that x minus 4 equals 0. Add 56 to each side, add 4 to each side. 13x equals 56. X therefore equals 56/13ths. And much easier here, x equals 4. So, resubstitute those values back in to y equals 18 minus 3x over 2. Y equals 18 minus 3x over 2. That one's straightforward. 18 take 3 times 4. Y equals 18 minus 12. Still over 2. 6 over 2. Y equals 3. This one, a bit more awkward with that, but if I put that into a calculator, I end up getting y equals 33/13ths. So the line and the circle intersect at an x value of 56/13ths with a y value of 33/13ths, and also an x value of 4 and a y value of 3. What's happening there is the line is cutting the circle in those two places.